not only have I worked with case controls and families, but I've worked with a whopping big family as well from a really different population, and that's from Norfolk Island. It's a fascinating place. It's quite close to Australia. It's about 2 hours off the coast of Australia. But the most interesting thing about Norfolk is that the majority of people who live on the island can trace their ancestry back to a really famous historical event, and that's the mutiny on the Bounty. So this was a mutiny in the 1700s where Fletcher Christian, who was the lead mutineer, and his friends took the boat and some Tahitian wives that they had at the time and got rid of the people who didn't want to go with them and took that boat as a mutiny. Generations later, they were rediscovered in the 1850s and the population was then getting bigger. They were running out of food and water. So Queen Victoria, who heard about this, decided to grant them Norfolk Island, which was an uninhabited island, had no Indigenous population, very hard to get to even though it's fairly close to Australia. And most of the people from Pitcairn moved there. And so most of the people on Norfolk can trace their ancestry all the way back to the Bounty, 12 generations ago, and also that gap where they went across to Norfolk. So I've been working with them since the year 2000. It's an isolated population.
And I imagine as all isolated, a lot of inbreeding.
Well, there's a couple of things. So there's a limited gene pool, which in some ways makes it easier to identify genes for disease. All the people who live there have the same food, the same water, very low levels of pollution, all of those sorts of things. So the environment is pretty much the same. And so if you take those two things into account, it's easier to track down the genetic side. If you've got a very large family, you've got it in a same environment, and you've got a chance of the same kind of genetic homogeneity. So that's what we've been doing. We've been working with them since the year 2000, Population Genomics Project. And currently doing a project, we just did 1,158 whole genomes to focus on trying to identify chronic kidney disease genes because they have high levels of that on the island. But we've done other studies.
Because as a result of inbreeding, there is a higher frequency of the genetic diseases.
Yeah, and that's exactly right. It's higher what's called homogeneity. That you tend to find things amplified. And even as an example, migraine. So migraine, hard to know because there hasn't been any big studies in Australia, but it would be at least 12% of the population would be affected in Australia by migraine. But on Norfolk, it's 25%. And that's exactly what you find if you do have an isolated founder effect population. You'll find this amplification. Yeah, been absolutely involved in working with families, with populations for many years, and I love doing it.